So we're going to go over our second day of notes for verifying trig identities. One of the important things to remember here is the difference of two squares. So if you have one expression squared minus a second expression squared, that can always be factored into the first expression plus the second expression times the first expression minus the second expression. Okay, so this can be done with trig functions as well. So for sine squared x minus 1, I'm going to let a be sine x, and I'm going to let b be 1. Okay, so I can see that I have a squared minus b squared. So this is going to factor into sine x plus 1 times sine x minus 1. Okay, so this is going to be a trick for verifying trig identities, and you want to be able to get this pretty quickly. For our second example, my a is going to be the secant of x, and my b is going to be the tangent of x. So you can see I have a squared, so secant squared, minus b squared, where b is the tan squared. So this is going to factor into the secant of x, so a, plus our b, which is this case is tangent of x, times our a, secant of x, minus the tangent of x. Okay, take a second, pause the video, see if you can factor the third example. Okay, so hopefully you saw in this case a is 1 and b is the cosine of x, and it factors into 1 plus cosine of x times 1 minus cosine of x. So our trick today in verifying trig identities is we're going to be using the conjugate sometimes. So conjugate is sort of similar to when we were rationalizing denominators. Okay, if you have a minus, you are going to multiply by those same two factors with a plus. But hopefully you'll recognize that that is like this side of our difference of two squares formula. So quickly, this is going to become cosine squared of x minus 1. Okay, if you are not convinced of that, if you don't see this, try multiplying this out using FOIL or the box method or the distributive method, okay, and you'll see that it simplifies to this. Similarly, our next one, we are going to multiply by the conjugate, which is going to be cotangent of t. We're using the opposite sign, so we're using plus the cosecant of t. Okay, and again, using our difference of two squares formula, quickly you want to be able to say that this is cotangent squared of t minus cosecant squared of t. In our last one, we have 1 plus cosine x, so the conjugate is going to be 1 minus the cosine of x. And when we multiply that, 1 times 1 is 1 minus cosine squared of x. Okay, and so it'll be important that we can both go from the difference of two squares this way to the two factors, and also go from the factors to the difference of two squares. Okay, let's look at our first identity. We have the cosecant of x minus the cotangent of x squared, and the whole quantity is squared, equals 1 minus the cosine x over 1 plus cosine of x. Okay, I think that this side is more difficult because it has division. So that's where I'm going to start with. So I have 1 minus cosine of x over 1 plus cosine of x. Okay, so this time I'm starting with the right-hand side. And my trick is I am going to try to multiply by the conjugate, because I also know if I multiply by the conjugate, I did this up here, I'm going to get 1 minus cosine squared of x, and hopefully you are starting to recognize that as sine squared of x. Okay, so having something squared, one function squared, is actually going to be more simple than 1 plus another function. Okay, so I have my same expression, but I am multiplying the top and the bottom by the conjugate. And I am always keeping in mind where I want to get to. Okay, so then this is going to simplify to this. I don't think it's ever good to multiply out unless you absolutely have to. You have no other options. So I am going to write this in condensed form, 1 minus cosine x. I have that factor twice, so that's going to become that squared. And then on the bottom, I can see that this becomes 1 minus cosine squared of x. So now I'm trying to simplify a little more. So now I have 1 minus cosine of x squared over the sine squared of x. So I feel like I'm in a kind of a tough spot because I have this expression and it doesn't look like this. Do not get disheartened if this happens. It happens a lot when you're verifying trig identities. What you want to do next is, so we started with the right-hand side because it looked more complicated, and we worked as far as we could, but it didn't get us where we needed to be. So now let's multiply. Let's start with the other side. So we have cosecant of x minus cotangent of x squared. So now I'm starting with the left side, and I'm just doing it here, and I'll show you why in a minute. So I'm doing it in a separate space. So I am looking at this, and I can see that eventually down here, I did get to things that were in cosine and sine. I never got to something that was in cosecant and cotangent. So I am going to start on this side by just rewriting everything in terms of sine and cosine. So cosecant of x is 1 over the sine of x. And cotangent of x is the cosine over the sine of x. And I can see that I have this whole thing squared still. So now I notice that I have a common denominator. And the reason I'm looking for this is I notice that I have a denominator here. So I am going to rewrite this. I still have this squared expression as 1 minus cosine x, and that's all over the same denominator, sine x. But this looks pretty good to me. This is equal to, the numerator would be squared and the denominator would be squared if I used my properties of exponents. So what I am going to do is I am going to rewrite the rest of this under here to finish my verification. So I'm rewriting this step as 1 minus cosine x over sine x. That whole quantity was squared. So that was this line. Now that was equivalent to this line. I'm always checking to make sure I'm copying correctly. And that was equal to my original left-hand side. So I've been able to verify, So I've been able to verify my identity. Okay, so let's look at it backwards. Cosecant x minus cotangent of x squared. This is 1 over sine of x minus cosine x over sine of x. I still have my squared. I still have my squared. This is equivalent to this. I can see it's equivalent to that. Sine squared is 1 minus cosine squared of x. And this I can see is equivalent. Okay, so if you ever get stuck, you just start working on the opposite end until you find a meeting place and then you rewrite it so it's all in one step. This you can just mark as extra work. Okay, not part of solution. Okay, so this was my work. You want to make sure, again, same as the ones we were working on yesterday, nice, clean, all of your equal signs are lined up. You start with one side, you end with the other side. Okay, you have all nice, clean steps showing from one to the next. Okay, if you have something that's equivalent and all your steps are right, that's fine. If yours goes backwards the other way, that's fine. Okay, you just have to make sure that each step makes sense from one step to the next. These are difficult. They take lots of practice. Okay, our next one. Again, practice. I am looking at these two sides. They both have fractions. I am thinking that addition in the denominator is more complex than a single function in the denominator. So I am going to rewrite my right-hand side first. Okay, and now, since I see cosecant t plus 1, whenever I see a function plus 1, it's a clue to me that I want to try to multiply by the conjugate. And remember, whatever I multiply the bottom by, I also need to multiply the top by, because then that's like I'm multiplying by 1. So now I get cotangent of t times cosecant of t minus 1 over cosecant of t squared minus 1. Here's another little trick I did. When I knew I was working on identities, I made this little cheat sheet for myself because these are the ones I don't remember well. I wrote the one I always remember, sine squared x plus cosine squared x equals 1. I figured out my one that related cotangent and cosecant by dividing both sides by sine squared. I found my one that related tangent and secant by dividing by cosine squared. And then I always am looking for something to be equal to 1. And so I rewrote these like this. So now I can see that my cosine squared, if I look at this, cosine squared minus 1 is going to be equal to cotangent squared of x. So this is going to become cotangent t times cosecant t minus 1. And my cosecant squared t minus 1 is equal to the cotangent squared of x, of t. Sorry about that. So now I can see that one of my cotangents is going to divide out, and I'm left with cosecant of t minus 1 over cotangent of t, which is what I wanted. So I have verified my identity. Okay, this little cheat sheet, I think the step that will confuse you is here, right? Anytime you see something squared in a 1 or two of your trig functions squared, you are looking back at these identities and seeing if you can manipulate it all. Okay, so when I saw cosecant squared of t minus 1, I saw this. How can I get it to look like that? I can subtract that 1 from both sides, and that's where I got the cotangent squared. Okay, please watch the next part of the video. Please come for extra help if you need it.